Namaskar, welcome to Atmiya University. I am Dr. Govind Vagadiya, representing Atmiya University Indian Knowledge System Cell. Today, in this session, we will discuss ancient Indian metallurgical advancement and its glory. Here I would start with Sanskrit saying regarding knowledge that says, न चोरहार्यम न च राजहार्यम न भातृभाज्यम न च भारकारी व्यय कृते वर्धति नित्यम विद्याधनम सर्वधनम प्रधानम, meaning the wealth which cannot be stolen by thief, neither can be annexed by rulers, the wealth which cannot be divided into brothers, the wealth which is not burdensome, and feather on the crown is this wealth increases multifold with if we spend it more and more, and that is the wealth of knowledge. We Bharatiyas have enriched knowledge of metallurgy since ancient time period, and nobody could snatch it from us till dates. Today we explore the remarkable achievement of ancient Indian metallurgy, a rich tradition stretching back to millennia. Borrowing the wisdom of Sir Isaac Newton, if modern scientists have seen farther in the field of science, it is because we have stood on the shoulder of ancient giants who have created rich heritage of metallurgical and other scientific know-hows. This aptly describes how later generation built upon the foundation knowledge laid by the metallurgical pioneers. Here we have the content of Introduction to Dhatuvad that is to be discussed today. First one is historical documentation around Indian Peninsula. The section likely discusses the historical text and records that provides information about ancient Indian metallurgy. Section on ancient non-metal and alloy deals with detail about the specific metal that early Indians were able to work with. Another section we will also discuss historical artifacts, evidences, archaeological finds that provide evidence of ancient Indian metal working. These artifacts could be tools, weapons, jewelries, or other objects. We will also discuss here the future opportunities for explorations, the potential for new discoveries related to ancient Indian metallurgy. This could involve examining existing artifacts with a new technology or excavating new sites. Introduction and history. Metallurgy, the science and technology of extracting metal from rare ores, has a long and rich history in India. Archaeological evidences suggests that Indians were working with metals as early as 6000 BCE. That's long period of time. Early metalworking, the Indus Valley Civilization 3300 BC to 1300 BCE was one of the earliest civilizations to develop advanced metalworking techniques. Indus Valley people were skilled in working with copper, bronze, gold, silver, lead, tin, and many more. They used this metal to create a wide variety of objects, including tools, weapons, ornaments, and statues. Iron Age period. In Iron Age period, the use of iron in India dates back to around 1200 BCE. The development of ironworking has a profound impact on Indian society. Iron tools and weapons were more durable and effective than those made with bronze or copper, which led to advances in agriculture, warfare, and construction. And if we discuss later developments, over the centuries, Indian metal workers continued to develop a new technique and improve their skills. By the medieval period, they were master of working with wide variety of metals including zinc, brass, and steel. Indian metalwork was renowned for its beauty, craftsmanship, and Indian metalworks were in high demand throughout the world. In conclusion, we can say that the long history of metallurgy in India is a testament to the ingenuity and skill of Indian metalworkers. Their knowledge and techniques continue to influence metalworking today also. Next. Here we have the list of ancient Indian known metals and alloys. First one is copper. Copper was known as tamra, iron was known as loha, gold was known as suvarna, mercury, that is parad, zinc was known as yashad in Sanskrit, silver was known as rajat, beryllium was known as vandurium, tin, that is vanga, lead, that is known as nag or shish, brass was well known as pittal. This list offers a starting point for exploring the fascinating world of ancient Indian metallurgy. Each of these metals has its own unique properties and history of use in India. Further research can reveal details about the techniques used to extract and work with these metals, the objects were made from them, and the role that metalworking played in ancient Indian society. This list showcases the rich vocabulary of Sanskrit for the precious metal, that is gold. First name is Kanchan. We can also say Kanchan or Kanchan, a popular name for gold appearing in many ancient Indian texts. Another one is Swarna, also found extensively in literatures. Next one, that is Hiranya, evoking ideas of brilliance and radiance. This term is often used in religious context. Then another one is Jwalan, referencing the characteristic sign of gold. Another one is Sharved. This poetic term literally translates to light that goes everywhere, highlighting the expensive quality of gold's luster. Another one is Dhatu Pushpa, meaning flower of metal. This term emphasizes the beauty and value of gold. Next one is Shyam. Interestingly, this name can also mean the dark, specific shade of gold, possibly a gold alloy. The significance of names are many, but we have discussed here some of them. Like the existence of so many names for the gold in Sanskrit reflects the culture, technological, and economical importance of this metal in ancient India. These names not only serves as descriptive terms but also carried symbolic weight associated with concepts like wealth, purity, and divinity. Developing deeper into these names can provide valuable insight into the cultural, social significance of gold in ancient India. It can be interesting to explore how these terms were used in religious texts, works of literature, and historical records. The Vedic Age in India witnessed remarkable advancements in various scientific fields, including metallurgy. These advancements weren't just practical achievements but also documented in ancient scriptures, forming a rich heritage of metallurgical knowledge. Several ancient Indian texts offer insight into metallurgical practices. The Vedas themselves contain references to metals like gold, silver, copper, and iron. The Arthashastra, a well-known Kautilya Shastra, and another that detail technique for mining, refining, and alloying of metal. Treatises like Shukraniti and Manav Dharma Shastra also mention metallurgical processes and the importance of metals in society. The scriptures offer valuable information on metal identification and processes as well as properties. They describe the distinguishing features and applications of different metals, extraction and refining techniques, that is, references are made to methods like fire, assaying, and washing for purification. Some alloying practices are also depicted. Text mention the creation of stronger and more versatile alloys like bronze, copper plus tin, and some other that like wood steel, high carbon steel famous for its sharp blades. So the knowledge preserved in this scripture laid the foundation for Indian metallurgical expertise. These techniques continued to refine for centuries, influencing metalworking practical across the region. Studying these scriptures also allows us to appreciate the ingenuity and scientific understanding of ancient Indian metallurgists. The Yajurveda mentions it a variety of metal, demonstrating the deep metallurgical knowledge of Vedic people. The verse here mentioned enumerates metals such as gold, iron, lead, tin, and copper. It says Hiranyam chame, Ayashwame, Sisas chame, Tripushchame, Shamam chame, Loham chame. Extracting these metals from ores requires advanced techniques. The Vedic people must have possessed extensive knowledge of metallurgy to accomplish this. The Atharva Veda describes the cosmic personality using the colors linked with various metals. The shlok says, Shyamamaya asya mamsani, lohitam asya lohitam, trapabhashmam haritavarnam pushkaram asya gandha. Here, this comparison associates the flesh with iron, blood with copper, body with tin, smell with lead. The Chandogya Upanishad, verse 1.6, refers to a nail cutter made of iron, highlighting the practical use of metals in daily life. Additionally, copper is mentioned, further providing the knowledge of various metals. The text from Ved also discusses the alloying, the process of combining metals. The slok says, Tadyatha lavanaina suvarna sandadhyata suvarnaina rajatam, means it discusses how metals are joined. The gold is joined with salt like borax. Silver will be merged into the gold. Tin with silver. Lead will be merged with tin. Copper will be merged with lead. This suggests the Vedic metallurgical understanding regarding metalworking, refining, and alloy formation long before modern metallurgical techniques. The Vedic texts provide remarkable evidence of early medical knowledge and metallurgy. One such story tells of a queen. Story title is Consort of Khela, who fought bravely in battle but lost one leg in process. However, she did not succumb to her injury. Instead, she prayed to the divine physicians, the Ashwini Kumars, who performed a miraculous surgery that replaced her missing leg with an iron steel prosthetic, enabling her to fight again and eventually defeat her enemies. The shloka says in hymn 6, that is, Charitram hi veriva chedi parnam aja khelasya pratakmayam sadhyo jange ham ayashi vishpalaye dhane hite sarvatre satarve prati adhatam. This story highlights advanced surgical processes known to the Vedic people. Knowledge of iron and steel processing is also depicted in this slope. And this belief in divine intervention combined with scientific method is also depicted in this shlok. Here we are discussing the archaeological evidence. Just as mathematics and astronomy from Sanskrit text align with modern knowledge, ancient India's expertise in metallurgy and mining is supported by archaeological evidences. Remarkable discoveries are depicted over here. First one is Singabam copper mines, a 250-foot standing monument showcasing advanced mining skills. Another one is Hutti gold mines, a 600-foot vertical shaft providing deep mining capabilities. This finding highlights the technological advancement in mining at least 3000 years ago, demonstrating India's rich metallurgical heritage. Beyond archaeological discoveries, epigraphy and numismatic also confirms India's metallurgical expertise. Some key examples are over here. Vishnu Padagiri inscriptions says Sanskrit records by King Chandra, that is 5th century AD, highlights metallurgical advancements. Another example is Gupta coin. It reveals refined metalwork and mining techniques of that era. These sources further prove India's mastery in metallurgy and mining in ancient time. Here in this slide we are discussing Arthashastra on mining. Like Kautilya emphasized mining as a major source of revenue. The shlok says, Akara prabhava kosha koshat dandya prajayate prithvi kosha dandabhya prapyate kosha bhushana. Meaning of this shlok is mines sustain the treasury funds the army, both help conquer the earth. This proves mining's economical and strategic importance in ancient India. Kautilya also emphasized state management of mines, assigning the responsibility to a director of mining, an expert in geology and metallurgy. Key duties of that director of mining are survey for mineral deposit to start new mines, renew old abandoned mines for continued resources extraction, prioritize gold and silver, detailing their ores, refining methods, and other metals like copper, lead, tin, and iron. And last one is the supervise salt mines managed separately by Lamanadhyaksha, that is called sole superintendent. This highlights India's advanced mining administration. Kautilya favored large mines even if they produces lower value minerals. Why? Because continuous sales from such mines ensure a steady revenue stream, unlike high value items that had limited buyers. Interestingly, despite emphasizing mining as an industry, Kautilya does not focus on coal, iron, or steel, metal considered crucial for heavy industries. This omission is curious because during this time, Greek invaders under Alexander were highly interested in importing Indian steel and iron for superior sword making. Could this be intentionally secrecy? Perhaps Kautilya deliberately avoided discussing these metals to protect India's strategic resources. However, Kautilya does provide detailed explanation on types of ore and their locations, metal extraction techniques, and economic benefit of mining. Modern C14 carbon 14 dating studies by metallurgists confirm the existence of ancient mines producing silver, copper, tin, zinc, and lead, validating Kautilya's description. Thus, Kautilya's work remain valuable sources in understanding ancient India's advanced mining industry. Studies including carbon 14 dating have confirmed that several ancient mines existed in India, producing silver, copper, tin, zinc, and lead. Some of the major mining sites and estimated periods are depicted over here. Some examples are Rajpura, Dariba, Udaipur, Rajasthan; Hatti, that is in Karnataka; Zaharmala and Ambamata, that is in Rajasthan; Komarna Hali and Tadana Hali, that is in Karnataka; Pandu Rajar Dhibi, that is in Bengal; and Alamgiripur, Rajasthan; and last one, that is Varanasi. These findings highlight India's deep-rooted expertise in mining and metallurgy, dating back over 3000 years. According to Rasarnava of Govind Bhaga, written between the 9th and 11th century AD, a pure metal possesses distinct characteristics when melted in a crucible. The text states a pure metal neither produces sparks nor bubbles, nor does it spurt or emit sounds. It shows no surface lines and remains tranquil like a gem as it flows from the furnace. The Sanskrit verse says like this: Na vispulinga na cha uddudasya yada na rekha patalam na shabda mushagatam ratnasamam sthiram cha tada vishuddham pravadanti loham. Here loh means not iron, but here it depicts the metal. To remove impurities from the firmly attached to ores, often causing odor and defects, furnaces played a crucial role. Impure metals were mixed with other substances, allowing unwanted material to burn away. This refining process ensures the production of high quality metals for crafting tools, weapons, and ornaments. The precise metallurgical knowledge preserved in texts like Rasarnava demonstrates the scientific advancement of ancient India. This expertise in identifying and refining metal laid the foundation for the high quality metalwork that became renowned across the world. Here the depiction is provided for degradation of metal, a common phenomenon that occurs due to factors such as exposure to air, moisture, oxygen, and various acidic or alkaline material. Metal degradation has been observed for centuries, and ancient Indians had a deep understanding of this process. An excellent example of this knowledge is Delhi iron pillar, a magnificent, efficient structure that has stood the test of the time. The pillar, despite being exposed to the elements for over 1,000 years, shows minimal signs of corrosion. It is testament to the advancement and scientific understanding of metal preservation. Now let's dwell into the process of metal corrosion. Metal, when exposed to environmental factors, begin to degrade at different rate. The rate of corrosion varies based on the type of metal. Ancient texts provide us with valuable insight into how metal degrades. In Sanskrit, it says Suvarna Rajatam Tamra Tikshnavandra Vunjagama Lohitam Shaddidham Tascha Yatha Purvam Tadakshaya. This translates to gold, silver, copper, iron, lead, and tin are the 6 types of metals which undergo self-corrosion at a slower rate in the reverse order. What this means is that gold and silver degrades very slowly, while tin, lead, copper are more susceptible to corrosion. This is crucial information for understanding how these metals react over time and how we can prevent their degradation. Additionally, The same text provide guidance on cleaning these metals. Slok says, Trapushishakam, Tamranam, Ksharam Lodak, Varibhi, Vashmabdi, Kamasya Lohanam, Shuddhi Plavo, Dravashya. This translate to tin, lead and copper may be cleaned with alkali and acids. Iron, bronze and copper alloys are cleaned with ash and water. Here are some ancient Indian antiquities derived from various archaeological sites in and around Indian peninsula. The picture shows the coin of Samudragupta with Garuda pillar currently exhibited in this reference museum. Another one example here we have shows the famous iron pillars of Delhi, which Charaka Samhita is standing from years now without deterioration. And many that shows the metallurgical fields, but in metallurgical fields of behavior, science, technology. Another example is here we have the famous bronze Chol statue as a developing country. Currently lies at Metropolitan Museum of Art was developed in New York City. And this depicts the advancement of redeveloping metal, but alloys and alloying science like revival of Indian knowledge system. This picture shows the well-known Dajer